Here's one more problem similar to something you might find in Chapter 6 of your textbook, and that is an equation. Now, this is not just a polynomial. This is a polynomial equation because now we have the equals 0 as part of it. And we're asked to solve this, which means our job is to find a magic value of x or multiple magic values of x that will make this expression true. The reason we've started with factoring is because factoring will help us with this solution. So let's see if we can factor this polynomial on the left-hand side. Let's not worry about the equals 0 yet. I do notice that there is an x in each of these terms, so if nothing else, we can factor out an x and leave behind x squared minus 5x plus 4, and then keep the equal 0 there. Don't drop it off because it hurts so much to write 2 extra items. Keep it there. Can we factor this? Well, let's see. It's a quadratic, and it's in the form that we normally can factor. So how about an x? I don't know why that dot's there now. You just have to ignore that. X and x as the leading terms. And now we're trying to put constants there and there that not only will multiply together to give us that plus 4, but then when added together as coefficients of x in the cross terms, we will also produce the minus 5. Now you can fiddle with different cases for that, but it turns out that those numbers are negative 4 and 1. So x times x gives us that x squared. Negative 4 times negative 1 gives us that plus 4, and the cross terms of negative 4x and on the outside negative x added together during the multiplication produces the minus 5x. So we've factored this polynomial on the left-hand side of the equation. And the reason we do that is because now we can basically just read out the solutions. We're going to use something called the zero product property, which is it's a property that sounds all fancy, but it makes total sense, I think. If you have a bunch of things multiplied together and that product ends up turning into a 0, then that means that one or more of these items in the product itself had to be 0, because otherwise you're not going to get 0 when you do this multiplication. So by what I'll abbreviate it, the zero product property, either x is equal to 0 and or x minus 4 is equal to 0 and or x minus 1 is equal to 0. And so from that, we get a list of 0, I'm going to put them in numerical order, 0, 1, and 4 as the values for x that when plugged into this, and so also when plugged into that, will produce the 0. And you can try it if you want to check these. If I plug in x equals 0, it's pretty certain that turns into 0. If I plug in x equals 1, I will have 1 minus 5, which is negative 4, plus 4, 0 again. And you can check the 4 if you want to. Plug in a 4 up here, and that will also produce a 0. So these are our solution values. Now, it's tempting to extend this zero product property into places where you shouldn't. This is a very common mistake. So just as a for instance, let's say I was solving an equation which had the exact same left-hand side, but instead of equals 0, it's equals 5, right? You cannot then make a list that says, well, then either x is 5, x minus 4 is 5, or x minus 1 is 5, right? Don't do that. If this times this times this is equal to 5, that means this could be 1, this could be 1, this could be 5, or 1, 5, 1, or negative 1, negative 5, positive 1, or, square root of 5 and some other things. There's tons of ways for this multiple here to give us a 5 back. So the zero product property doesn't extend there. But when I have it equal to 0, an expression like this, the only way for the left-hand side to produce a 0 is if that or that or that was 0. So the zero product property is useful, but don't go crazy with it.